Alright, so here are the hints for homework 17. Alright, for problem 2, we have the speed of light, c, is equal to the distance divided by the time. We want to solve that equation for t, of course. Sorry, that was a little stupid notification. Make that go away. Alright, sorry. And then, of course, that's pretty simple. Here, I'll do it right here. So the time is equal to, the time and the speed of light switch places, right? The distance divided by the speed of light. All right, and I believe they give us, they give us a distance of 8,000 parsecs. All right, so uh, let's see. So the distance is going to equal 8,000 parsecs. And so remember that, of course, the speed of light is in meters per second. 3 times 10 to the 8th meters per second. So what we need to do is change the distance to meters. That's probably the simplest way of doing this. And so this is the distance they give us in the textbook, 8,000 parsecs. And you can look up the fact that one parsec is 3.1 times 10 to the 16th meters. Here, let me write that down. So here's the conversion, right? One parsec, right? So that the parsecs cancel. The parsecs go in the denominator. Is equal to 3.1 times 10. Here, let me extend this division. Times 10 to the 16th meters. That's supposed to look like a 16, sorry. 3.1 times 10 to the 16th meters. And so that will convert it, right? The parsecs will cancel, and that'll convert it. And then what you're going to do is you're going to use this number, whatever this number is. There's going to be some number. Okay, I'll leave that to you, right? That's part of the problem of meters. And you're going to put that in right here for distance. And then, of course, the speed of light, c, is, you should pretty much know this value by now. 3 times 10 to the 8th meters per second. Okay, and so what you're going to do is you'll get the answer, the answer of time, and that answer is going to come out here. Let me do this over here. The answer will come out in some number of seconds. Okay, what you should really do to get a really good sense of this, a better sense, it's going to be some tremendous number of seconds. Convert that number of seconds to years. Okay, so here I'm going to do that right at. You guys remember how to convert to from seconds to years. I mean, it's a pretty easy process. So convert. That's supposed to be a C. Convert to years. And that, if I remember this problem, it's a photon of light leaving the center of the galaxy. How long does it take to get to to the Earth, which is roughly 8,000 parsecs away? All right, so convert it to years, and that will help you with that. Well, that'll answer the problem. All right, let's do number 5. All right, so here's the beginning of doing problem number 5. This equation, the velocity is equal to, it's the same as the velocity is equal to distance divided by time. I mean, this is the exact same thing, right? However, this is for something that's moving in a circle. All right, so let me explain what I'm talking about here. So if we have a circle that has some radius r. So this is just any general circle, and there's a circumference, right? So this, the distance to go all the way around the circle, that's called the circumference, c. And you might remember this from geometry. The circumference of any circle at all is 2 pi times the radius of the circle. Right, and so the distance is 2 pi times the radius, right? That's the d part, and if you're going in a circle, the time that takes is called the period, and so I just used p for period. All right, so this particular problem is asking how long does it take the sun to go around one orbit around the galaxy, and for that we want to rearrange this equation and solve for p, right? So we're looking for the period because they give us the velocity. They tell us the velocity. I think it's in they give it to us in kilometers per second. So that this part is given. This is given in given. So this is given in the textbook in kilometers per second. Anyhow, let's rearrange that equation and solve for p. Again, it's the same kind of thing. The p and the v are basically just going to switch places. So the p, that's supposed to be a p, is equal to 2 pi times the radius divided by the velocity. All right, so the velocity is given to us in kilometers per second, as I mentioned. So what we're going to want to do to cancel, we want the r to be in kilometers this time. All right, so what we need to do is convert the distance that they give us. The distance r, I think, is the same as problem 2, 8,000 parsecs. But this time we're going to convert it to kilometers. All right, so how to convert the 8,000 parsecs to kilometers? We're going to use this conversion. 1 parsec is 3.1. That's supposed to be a 3.1 times 10 to the 13th kilometers. And of course the parsecs will cancel, and that'll give you some number of kilometers, right? Which is exactly what we want. And then to solve for the period, right? The period, of course, going back to that equation that we just had, is equal to 2 pi times the radius. Okay, so we're going to use this number right here for the radius, and then we divide by the velocity that they give us, which is already in kilometers per second. And so that gives us some number of seconds, right? So, because if you think about the units, the radius here is in kilometers. This is kilometers per second, so the kilometers cancel, and it's 1 over second, so the seconds go up to the numerator. So you're going to get some number of seconds. All right, so and again, whatever this number of seconds is, it's going to be a really large number, but what we're going to want to do is convert this to years. So convert. I'm supposed to say convert, sorry. That didn't come out very well. Convert. Supposed to be in there. Sorry. 2 years. Oh, man. So sometimes I don't push down hard enough on this touch screen. Sorry about that. Convert to years. All right, and you guys remember how to do that. I'll quickly do that So if you had the period is equal to some number of seconds, some number of seconds, then you just play this little game, right? You know there's of course 60 seconds in 1 minute, and then there's 1 minute. Sorry, there's 60 minutes in 1 hour. 60 minutes in 1 hour, and then there's 24 hours in 1 day, and then you could go with there's 365 days in 1 year. All right, and so that would, so you take whatever this number is right here, you divide by 60, divide by 60 again, divide by 24, and then divide by 365. All right, and that'll give you the number of years, and it's in the millions, just to give you, what the answer should be. All right, let's do problem 8. All right, so here's problem 8, or they give us that the supermassive black hole at the center of the galaxy is 4 million times the mass of the sun. So it's 4 times 10 to the 6 times the mass of the sun. So you just you want to put that into kilometers. So just multiply 4 times 10 to the 6 times the mass of the sun, which is of course 2 times 10 to the 30th kilograms. Then it's in kilograms, and then you use the Schwarzschild radius. That's really what they're asking. What's the size of the supermassive black hole at the center of the galaxy? And so just to remind us, our Schwarz, that's supposed to be an H. Anyhow, our Schwarz is equal to. Remember, there's only really one variable, and it's the mass, right? The Schwarzschild radius is just 2 times big G. Remember, big G is the universal gravitational constant. That's 6.67 times 10 to the minus 11th times the mass, right? That's the variable, divided by the speed of light squared, right? And so you just whatever this number turns out to be, you're going to use that as m, right? And that's the problem. And then of course remember the answer comes out in some number of meters, right? The Schwarzschild radius is in meters. All right, just to remind you, I'll just write these. I mean, you guys know this, I'm sure. Big G is 6.67 times 10, that doesn't really look like a 7, times 10 to the minus 11th. Oh man, here, I gotta erase that, sorry. It doesn't look like an 11th. Where's the eraser? Sorry about that. So that's supposed to be times 10 to the minus 11th. All right, and then of course remembering the speed of light is 3 times 10 to the 8th meters per second, right? All right, but remember you're squaring that. Okay, so you gotta square that. All right, so there are the hints for homework number. What homework was this? 17, I think. Yes, the hints for homework 17. All right, and that's due, of course, by Monday. What's Monday? It's going to be April. Hold on, just a second. Monday, April 6th. Okay, so by 5 o'clock, make sure you get that done. All right, and here, so let me end this.